Okay, for today's video, we're going to look at solving some equations and inequalities. So again, just have two sheets of lined paper and copy down the problems and solve them along with me, please. First one we're going to solve is a quadratic inequality. 2x squared minus x is greater than 10. Okay. Now, we solve this as if it's an equation. So let's put it in standard form first. So let's subtract 10 from both sides. 2x squared minus x minus 10 is greater than 0. Let's change it to an equation. And we solve it as if it's an equation. Lead coefficient is not 1, it's 2, so we'll try the factoring. 2 times negative 10 is negative 20. The factors of negative 20 that add to negative 1 are negative 5 and 4. So we draw a fraction bar. This is a factor in, factor out method. That 2 that we had multiplied by, we need to divide by, and that starts off, parentheses, 2x minus 5, 2x plus 4. 2 divides evenly into both terms of my second parenthesis, so I divide it in. It goes in x plus 2 times. Bring down the other factor, 2x minus 5. Okay, so we factored. Now we set each factor equal to 0 and solve them individually. Subtract 2 from both sides, x equals negative 2. I would add 5 and then divide by 2, x equals 5 halves. So we have two values for x, negative 2 and 5 halves. Now let's go back to our inequality. Remember here is greater than, right? Greater. We take our two values, place them on a number line. So negative 2 and 5 halves. Negative 2 and 5 halves is between, that's 2.5. So that's between 2 and 3. We circle each. Since it's greater than with no equal to part, those circles remain open. Greater, like the oars of the boat, we shade outside. And now from our graph, now we write symbolically, these are all values of x that are less than 2. Sorry, less than negative 2. Or these are all values of x that are greater than 5 halves. So graphically, symbolically, and what's the third way? Yes, interval notation. We're going from negative infinity to negative 2, parentheses, union with 5 halves to infinity. So, good review of a quadratic inequality as well as factoring when the lead coefficient is greater than 1. Next, let's look at solving an absolute value equation. The absolute value of 3x minus 4 is equal to 5. Alright, for absolute value, it's by itself, it's isolated. So we break this up into two separate equations. Left-hand side, 3x minus 4 equals negative 5. And the right-hand side, we just drop the bars and copy as is. And now solve individually. Add 4 to both sides. Not going to show that. 3x equals negative 1. Continue solving. Divide by 3. X equals negative 1/3. For our other equation here, adding 4 to both sides. 5 plus 4 is 9. Divide by 3. X equals 3. Okay, now the thing about absolute value equations, you must check. Right? Equations that contain absolute value and equations that contain radicals, you must check them for extraneous solutions. Alright, so we go back to the original here. The absolute value of 3, replacing x with negative 1/3, times negative 1/3 minus 4, does that equal 5? Well, 3 times negative the third is negative 1, minus 4 is negative 4. Well, this isn't coming out right. Okay, well first let me, alright, make a correction here. No, we're all good. Alright, so, oh, here we go. Negative 1 minus 4 is negative 5. There we go. And the absolute value of negative 5 is 5. Sorry about that. So 5 equals 5. Plugging in 3. The absolute value of 3 times 3 minus 4, does that equal 5? 3 times 3 is 9, subtract 4 is 5. The absolute value of 5 is 5, so 5 equals 5. So both check, so both are solutions. 3 and negative 1/3. Next, let's look at solving a radical, an equation containing a radical. The square root of x plus 14 equals x plus 2. Alright, the radical is isolated, so square both sides. X plus 14 equals, please make sure you FOIL this, right? X plus 2 times x plus 2 is x squared, plus 2x and plus 2x is 4x, and 2 times 2 is 4. Quadratic, so let's put it in standard form. Let's bring the two things from the left side over to the right, subtract x and subtract 14. We have x squared plus 3x minus 10 equals 0. Now factor. Factors of negative 10 that add to positive 3 are positive 5 and negative 2. So x plus 5 times x minus 2 equals 0. Set each factor equal to 0. I'll skip that and go right to our two values, negative 5 and positive 2. And this was an equation containing a radical, so we must check. Going back to the original, the square root of negative 5 plus 14, does that equal negative 5 plus 2? Negative 5 and 14 is 9, square root of 9 is 3, and negative 5 plus 2 is negative 3. Negative 3 does not equal positive 3. So negative 5 is out. Check 2. The square root of 2 plus 14, does that equal 2 plus 2? Square root of 16 is 4. 2 plus 2 is 4, so 4 equals 4. That check. So we have only one solution here, an x value of 2. Okay, next let's solve a quadratic equation that is not factorable. So let's look at, let's see, this is number 4. X squared plus 6x equals negative 25. Quadratic, place it in standard form. X squared plus 6x plus 25 equals 0. There are no factors of 25 that add to 6. So, if it's not factorable, quadratic formula. Or complete the square. So we'll actually do this both ways. First, using the quadratic formula, pulling out our values of a, b, and c. A is 1, b is 6, and c is 25. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, I use parentheses as placeholders and then plug in the values. So we have -6 plus or minus the square root of, that's 36 minus 100, which is -64 all over 2. -6 plus or minus the square root of -64 is 8i all over 2. Let's split this up because oftentimes we have an imaginary root here, excuse me. So the direction would often say to write in the form a plus bi. All right, so we split this up. -6 divided by 2 plus or minus 8i divided by 2. So we have -3 plus or minus 4i. Okay. Now, let's use complete the square method. All right. So for complete the square, our lead coefficient has to be 1, which it is. Excuse me. And we want the constant on the other side. So I have x squared plus 6x plus blank. And if I subtract 25 from both sides, we have -25 plus blank. All right, so this is complete the square method. Now, what goes in each blank? Go to the coefficient of x. Divide that by 2. You get 3. 3 squared is 9. So we're adding 9 to both sides. Now, we've made this into a trinomial that factors into a binomial squared, x plus 3 squared, equals -25 plus 9, -16. We have x plus 3 squared equals -16. What undoes square? Square root. Square root both sides, and we have x plus 3 equals, remember when we compose square root, plus or minus, so this would be plus or minus square root of -16 is 4i. And one more step, subtract 3 from both sides. So x equals -3 plus or minus 4i. Okay, so this completes tonight's video. Thank you again.